Hi. That slide moved without me pressing a button. That's very clever. It's lovely to be here. Just wanted to quickly introduce myself. So my name's William Tunstall-Pedoe. I run a AI startup in London. We are looking at safe and effective general intelligence, so very much adjacent to the theme that I'm talking about today. We're about 50 people, venture-backed. I'm best known, though, for my last startup, which was a 10-year entrepreneurial adventure, another deep tech startup based in Cambridge. Got acquired by Amazon eventually after a sort of 7 years of pivoting and various adventures, and we built Alexa with the tech know-how in that period. And I was there until 2016. So obviously that worked out quite well. Amazon sold hundreds of millions of devices. It's a brand everybody's heard of. Everybody's used it. And what I'm doing now is an attempt to build something even bigger than that. And I've also spent quite a lot of time mentoring startups as well. So I've got a lot of expertise, a lot of experience, kind of talking to people, the next generation of deep tech and AI startups. So the purpose of this talk is to try and frame what's happening in AI at the moment. So as I'm sure you've noticed, AI has become very, very hot for about 9 months, since December at the end of last year. And I think it would be very useful to kind of frame it, to kind of give some definitions, to kind of explain why it's suddenly become so hot and why it's a moment in history at the moment with general intelligence. So you probably are familiar with these terms. They're thrown around a lot. AI is an extremely general term. It basically means making intelligent machines. And there's another term, machine learning, which people regard almost as synonymous with AI because it's used almost all the time in the same context. And that's because pretty much all of the AI that is done at the moment is machine learning. But machine learning means something quite separate. It means making machines learn, which is a distinct definition from AI. And within ML, it's a very specific type of algorithms that people spend almost all the time on, which is the statistical algorithms. They're essentially trying to learn weights in a formula. And of all the various machine learning algorithms, there's another term which we hear the whole time, which is deep learning, which is one specific machine learning algorithm, which is deep learning, very big neural nets. And neural nets have a key point I want to get across in this talk, is that deep learning has this magical property that it continues to improve the bigger the neural net and the more data you give it. And this is what has driven the advances in AI over the last 10 years. So the human race is generating larger and larger amounts of data. So one of the tailwinds for AI is more and more data is being produced. We all have smartphones. More and more people have smartphones. Those smartphones are getting faster and faster. So the amount of data that the human race is generating is exponentially growing. And most of the data that has been generated in the last 2 or 3 years. This slide is slightly out of date. All my data is just 2 or 3 years out of date, but the trend is absolutely the same. And the other really big trend that's been driving AI is increases in compute. So remember I said that deep learning gets better the more and more data that's given, and the bigger and bigger it is. So the amount of compute that's available, raw computing power that the human race has also been exponentially growing, and it's been exponentially growing for like more than 100 years. So this slide goes right back through various generations of computing technology. The key thing to understand is that the y-axis here is logarithmic. So that supposedly slightly curved line is actually more than exponential. So the amount of compute and power that you can purchase for a fixed amount of currency has been growing exponentially for more than 100 years. So those tailwinds have also driven huge economic benefits to big tech companies. So in 2010, there was only one big tech company in the top biggest companies, which was Microsoft. And a decade later, all the biggest companies are big tech companies. So that those trends of data and compute and the capabilities that have come with more and more data and more compute have driven economic benefit to the big tech companies, with the result that we now have multiple trillion-dollar companies that are big tech. And this trend is continuing. OK, one more definition, general intelligence. So this is an ill-defined term. And historically, AGI was a slightly kind of off-the-beaten-track, slightly niche term. It was the kind of the future, sci-fi future, the computers that you see in sci-fi. It's now become quite mainstream. But having said that, there's not a lot of consensus about what the definition is. So clearly the human brain has it. Everybody would agree with that. It clearly does many different things with the same algorithm. And people have got different ideas about when AGI is here. Is it going to be solving big scientific problems? Is it going to be inventing things that can't be invented? Or is it just a general capability like we're already seeing with LLMs? Which brings me on to the next thing, which is large language models, which I'm sure is a term that everybody's heard of. These are big deep learning models that do one thing, which is predict the next word. So you give them text, and they predict the next word. And having predicted the next word, you can then ask them to predict the word after that. So by repeatedly predicting the next word, they can write. And these models, the latest large language models, are absolutely enormous. So they have hundreds of billions of weights in them, and they've been trained on tens of terabytes of data. So they've been trained on meaningful amounts of the text, of the language that's ever been written. And surprisingly, with these absolutely massive models, they've started to do these emergent things that surprised a lot of people. They've started to be able to sort of act intelligently, predict words in a way that is very difficult to understand and shows cleverness, shows intelligence. This is like a really simple example of an LLM. And as I say, all they're doing is continuing the text. So this is like three very simple examples. One is a creative example. Give us a slogan for a startup. The green text is the continuation. So the green text was generated by the model. The black text is what was typed in. Something very simple like sorting is an emergent capability of these models. And general knowledge. So having been trained on the raw internet, it can tell you about cheeses or any other general intelligence, general knowledge type question because it's kind of learned it from seeing it in the training data. And what happened in December last year was that OpenAI launched a consumer product, ChatGPT, which is just essentially an LLM. So it converses with you, but the way it generates its half of the conversation is just by continuing the text. It's got some other innovations in this as well, but very simply, it's an LLM. It's also exhibited a little bit of a step change in capabilities, which took a lot of people by surprise. So the wave of, a big part of the wave of generative AI, a big part of the excitement that we've been seeing since December last year as a result of ChatGPT and its capabilities and its enormous adoption. So in just 2 months, ChatGPT got to 100 million users. That's faster than any other previous software product, which fully underlines the capabilities and excitement that LLMs and these very large models have started to have. OK, so this brings me on to general intelligence and LLMs. And one of the key things I want to talk about today is how language can be the substrate for intelligence. And this is why LLMs are so exciting. Natural language can be used to express arbitrary problems. It can also be used to express solutions to problems. So if you create something that automatically goes from problem to solution in a general way, you've got the beginnings of general intelligence. And this is something that we haven't seen before. So often when you train a machine learning model, it's doing something very specific. You're giving it data, you're telling it to classify into 5 boxes. It's doing that. It's in a small vertical area. Because these things are trained on language, they're able to talk about everything that you and I can talk about, and they're able to generate responses and answers to absolutely everything. So this is like a moment in history, incredibly exciting. This is the beginnings of general intelligence. And as I said, AGI was previously a slightly crank, slightly edgy thing. For me, one of the biggest events in the last few months was this paper being published, which is published by Microsoft, so completely mainstream, completely respectable. This is a 150-page paper where they evaluated OpenAI's latest model, which is GPT-4, and over 150 pages concluded that it's showing the beginnings of AGI. Sparks of AGI is what they put it. So you could make the case that AGI is already here. I think when we look back in 10 years, I think we will look at GPT-4 or ChatGPT as the beginnings of AGI, beginnings of it arriving. Having said all that, this technology is not without very significant problems. So one of the problems it has, like all deep learning, is that it's virtually impossible to explain the results. As I said, when you create a deep learning model, you're creating a formula with hundreds of billions or even trillions of weights. Those weights are initialized randomly. They'll then got to their final values by exposing them to astronomical amounts of training data. The end result is a formula which is taken where all the individual weights have taken weeks or months to get there. That's almost the definition of unexplainable, in my opinion. The people building them don't understand how they work. The models themselves certainly don't understand how they work, even though the LLMs will have a stab and confidently explain how they got there. They really don't know. Other problems include the fact that the data is often the raw internet, so it's exposed to all the biases and things that are wrong with the naked internet. Hallucination I'm going to talk about in a second. The other thing I mentioned in terms of confidence, so they generally always produce an answer. They almost never say, I don't know. They almost never qualify the answer. So when they're wrong, they say it confidently. They create answers that are plausible. And there's all sorts of short-term risks around their use as well. Intelligent spam, marketing, impersonation. So there is all sorts of concerns with this technology too. I want to talk about hallucination in particular because this is a particularly big one. So on the right here, you have a bio of me that was generated with ChatGPT. What's fascinating about this bio is that 40% of it is fiction. So 60% of it is accurate, 40% of it is completely and utterly wrong. But what's so fascinating is that I am probably the only person that could actually say which is true and which is false. Even close family, close colleagues would not be able to tell. The stuff that's been generated that's wrong is so plausible, it really would pass muster almost anywhere. It says, for example, I'm on the advisory board of the Centre for Computing History in Cambridge. I live in Cambridge. It's completely plausible I will be helping them. I've got no contact with them whatsoever. It's given me two co-founders for my first business. I Googled them. They're real people. They're actually very plausible co-founders for my first business. I've not met them. And worse, it's actually given references for all of this. So all of these false statements have got a little reference. They've got URLs. They've got headings. It even said the data to access them. They look like incredibly plausible web pages. You click on them, they're 404s. They've never had any content on them, completely invented, hallucinated by the model. I have a background in question answering, in search, in the creation of Alexa. I know the worst possible user experience you can have is to answer a question in a way that the user believes where the answer is wrong. So if you say, I don't know, that's a bad experience. If you produce a completely dreadful answer, that's a really bad experience. But at least the user knows it's wrong. But if you tell the user if you tell the user something's wrong that they believe that's plausible, they go away, the world is a worse place. These models do this almost by design. The other example, I've lost my slides, by the way. The other example, which just amused me, is ChatGPT creating a conspiracy theory for Building 7 of the World Trade Center that is completely novel. Not even the conspiracy theorists believe it. Was Building 7 demolished or did it collapse in a fire? ChatGPT answers it was demolished, but it was demolished deliberately for health and safety reasons. I mean, it's like somewhere between the two worlds, completely novel. Anyway, because of all these problems, there's been all sorts of press about fears and risks. The risks that people talk about are everything from the mundane disinformation, etc., right through to the destruction of humanity. There's been if you've seen the headlines, there's all sorts of debate about it. It's a considerable concern. There've been talk of pausing AI. There's all sorts of talk about regulation. There's all sorts of pressure to discover solutions to these problems and to manage the coming wave. But I want to end on a positive note, which is the possible benefits of AGI. So if we get it right, having machines that are very intelligent and can solve general problems and can solve problems in a way that's more effective than humans could creates absolutely enormous opportunities. So we're talking about curing disease. We're talking about advances in healthcare. we're talking about huge advances in productivity, so economic benefits flowing to everybody. This is if we get it right. Huge advantages in education. We're talking about everybody having their own assistant that can guide them, can help them, can give them the information they need, educate them, make them happier. So I actually want to defer to Mark Andreessen here because he wrote an extremely good essay on this. So he's actually more able to articulate it than me. So if you want to get a clear understanding of the positive case for AGI, that would be it. So that's what I had to say. I'll take questions now.
Thank you very much to you, William, and we've got some time for some questions, so please feel free to ask some questions on Slido. I do have one question just to start,
sure.
Which is, why and how did you calculate April the 11th, 1954 was the most boring day in history?
Okay, so that happened, okay, that's a story from my first startup. So my first startup, which eventually became Alexa, had technology that answered questions, understood natural language, could reason, and it had a huge database of the world. So it understood hundreds of millions of facts about the world. And by scanning that database of facts, we were able to work out what date was the least interesting, had the least happen. And it was April the 11th, 1954. We put out a press release. It was a fun thing. We had hundreds of thousands of articles in thousands of languages. And every April the 11th since, we've had further press for like 11 years. There was even a play was put on in Germany. Somebody actually created a play with that date. It was just like the most insane sort of viral PR thing that we did as our first startup. So it was a lot of fun.
Well, there you have it. Just choose a date and make that the national day of whatever's relevant.
Yeah, it wasn't made up. It was calculated. But but of course, the interesting thing is, having been the most boring day in history, it's now become a very interesting day because it's been designated as being the most boring day in history. So it almost became provably false the moment it was asserted.
Oh, that's kind of very strange. The observation of it has changed its state. I had one of the very first Amazon Echoes, and I mean, for me, it was like the Star Trek.
Not as early as mine, but
not as early as well. Clearly, I mean, you probably had one.
I was the first person in the UK to have one by about 2 years. Yeah.
Did you show it to people? Did they think
No,
you?
It was a secret prototype device, but
it just sat quietly and.
it kept going in a drawer whenever I had visitors and come out. But yeah.
So what was the point where you kind of accepted it as a general part of life? Because I think many people went through this phase where, I mean, for me, I did. I went round to someone else's house and they had one of these devices. And I heard my friend ask Alexa something. I said, what are you speaking? She's mine. What are you speaking to her for? And it was very weird how now that isn't the case.
It's really weird. It's like, so when I first was giving talks about it, I used to bring a device on stage and show people, because they'd never seen it. And I used to ask people to put their hands up if they'd heard of it. And then there was a point, I don't know, a few years in when everybody had used one, everybody knew what it was, everybody had got one, and it became completely irrelevant to demo it. And that happened really quite quickly.
I think so. Yeah.
It's been quite weird. And then you sort of see the cultural references to it. You know, I'm watching a Hollywood film. Or something, and suddenly somebody will start talking to Alexa in the middle of a film, and it still surprises me to this day.
Yes. Well, yeah.
Something that you created has that kind of extremely wide impact.
Yeah.
You talk to people on the other side of the world, they know about it. Yeah.
I think one thing that all of these devices do struggle a little with is that follow-up question, the context within which questions are asked. Do we have a time scale, do you think, as a kind of closing question on when we can see this happening?
Yeah, well, LLMs obviously are a step forward in natural language understanding and processing, and they can certainly do follow-ups with stuff put in the context. And Amazon's on record as working on integrating LLMs into Alexa. It's obviously, there's a lot of difficulties when you're putting something into production at that scale. You can play around with ChatGPT and see it doing stuff, but actually putting stuff into hundreds of millions of devices with a voice interface is potentially something that will take a while. But yeah, the technology is to create that step change improvement is already here.
And I think as language is evolving, I mean, generally we see new words being made up all the time. Can we see a future where the machines are starting to create their own taxonomy?
Yeah, one of the questions I asked ChatGPT is to coin a term for something that I need a term for. And it actually does quite a good job of that. So
It seems to be
that's
quite good at puns. A lot of these sort of models seem to be fine with that sort of thing. But I'm waiting for it to come out with a word that I don't know yet. And that's going to be really strange. But I think I might play with that. Oh, my goodness. What a fantastic person to chat to. Everybody, it's William Tunstall-Pedoe. Thank you.